Sometimes the biggest answers to our most complex technology problems are hiding in plain sight. And it turns out the key to the future of AI might not be in a massive centralized data center, but in the collective wisdom of the humble ant colony. So let's just chew on that for a second. A bustling ant colony and the cutting edge of artificial intelligence. What on earth could those two things possibly have in common? Well, the connection is deeper than you might think. The big answer is something called collective intelligence. And it's this really cool idea where a bunch of simple individuals doing simple things somehow create this incredibly smart, complex group behavior. I mean, no single ant has the master plan, right? But together, they build these amazing societies and solve complex problems. And that brings us right to the power of the swarm. Before we even get to the AI part of this, let's look at where this idea was basically perfected. Out in the wild. I mean, you've seen this stuff, right? Ants creating these perfect little highways to a food source, a flock of birds moving like a single organism to dodge a predator, wolves coordinating a hunt, or a school of fish moving together for safety. The amazing part is there's no CEO, no general shouting orders. It's all decentralized, all self-organized, and it just works. It's incredibly resilient and efficient. So the big question is, how do you get from a forest floor to a computer chip? Well, it turns out computer scientists have been looking at these elegant systems in nature and thinking, hey, we can turn that into an algorithm. And that's a whole field called swarm optimization. It's literally about mimicking that collective, leaderless behavior we see in nature to solve really tough, complex problems. And yep, the classic example of this takes us right back to our little friends, the ants. Okay, so picture this. Ants leave their nest. At first, they're just kind of wandering around randomly. But as they walk, they leave behind this little chemical breadcrumb trail. It's called a pheromone. Other ants, they're naturally drawn to paths with stronger pheromone smells. So here's the clever part. The ants on a shorter path can go back and forth more times, right? That means the short path gets a double, triple, quadruple dose of pheromones, way faster than the long meandering ones. And boom, before you know it, the whole colony has collectively figured out the absolute best, most efficient route, all without a single meeting or a manager. This whole idea, decentralized problem solving, is like the perfect antidote to one of the biggest headaches in AI right now, training these massive models. The way we do it today is super centralized and incredibly expensive. But what if we could train an AI model the same way an ant colony finds its lunch? Let's just put them side by side for a second. On one hand, you've got the old way, a centralized data center. That means a single point of control, a single point of failure. It's crazy expensive, and only a few big players can afford access. On the other hand, you have a decentralized network. It's spread out across tons of different computers. It's way cheaper because it uses compute power that's just sitting idle anyway. It's open, it's democratic, and because there's no single weak spot, it's way more robust. It's just a fundamentally different and maybe better way of doing things. Okay, but that brings up a really important question. If you have all these different computers, these agents all over the world, how do they learn to work together? How does any one of them know if it's doing a good job? Well, the answer comes from a really powerful branch of machine learning. It's called reinforcement learning, or RL for short. And you can basically think of it as learning by trial and error, but with a reward system. You try something, and if it helps you reach your goal, you get a reward, like a point. If it doesn't, you don't. Simple as that. Now, RL itself has a few different flavors. Some are value-based, some are policy-based, and then you've got these hybrid actor-critic methods that try to do both. But what happens when you have a whole swarm of these learners all at once? Well, that's when you step into the world of multi-agent reinforcement learning, or MARL. And this is where it gets really dynamic. Now you've got multiple agents, all learning and adapting in the same environment at the same time. And the moves they make don't just affect them, they affect everyone else in the swarm too. So in a system like this, you have all these different agents, they're all looking at the environment, taking actions, and getting feedback. But here's the really crucial part. They're also talking to each other, sharing information. That communication layer is the secret sauce that turns a bunch of individual learners into a truly coordinated, intelligent hive mind. So, we've got the swarm concept, and we've got the learning mechanism, MARL. But how do you actually make this work in the real world? With messy internet connections, different kinds of computers, all that chaos. You need a very special kind of algorithm for that. And there's one called SAPO that's a real game changer. I absolutely love this quote because it just nails the whole idea. SAPO, which stands for Swarm Sampling Policy Optimization, is built to let those aha moments spread like wildfire through the network. So when one single agent figures something brilliant out, that breakthrough doesn't stay isolated. The whole network gets to learn from it almost instantly. Here's how it works, and it's beautifully simple. First, every computer, or node in the network, trains its own little AI model on its own hardware. As it works, it generates experiences. Think of it like a report of what it tried and how well it worked. Now, here's the magic. If it has a successful experience, it shares that with the entire swarm. This creates this amazing shared library of what works. Then, other nodes can dip into that library, sample those successful experiences, and use them to get smarter, faster. It's a brilliant feedback loop where everyone is constantly teaching everyone else. Okay, so this isn't just theory or some lab experiment. There's a company called Gensyn that is actually building this right now with something they call their RL Swarm. The Gensyn RL Swarm is basically a living, breathing version of everything we've been talking about. It's a system where anyone, anywhere can chip in their computer's idle time. Doesn't matter if you have a top-of-the-line GPU or just a decent computer, and become part of this massive collective intelligence. It's totally decentralized, works with all sorts of different AI models and hardware, and it doesn't need perfect, super-fast connections to work. So, does it actually work? Oh yeah, the results are kind of mind-blowing. In a global test, this decentralized swarm approach was a whopping 4.8 times faster than the current state-of-the-art systems. And get this, they achieved that massive speedup in a test that was spread across 8 different cities on 3 continents. We're talking about a messy, laggy, real-world network, the kind of environment where a traditional centralized system would just choke. But the swarm thrives in that chaos. Its ability to share insights and adapt on the fly gives it this incredible performance edge. And all of this really leads to one final huge question. We've seen how nature uses swarms to solve impossible problems without a leader. Now we're building the digital version of that. So when collaboration is literally written into the code, and a new discovery can be shared across the entire globe in an instant, what's the actual limit for a global AI?
dream. We are the dream. Aside, the world's alive, riding the tide of the neon sky. Aside, we reach, we climb. The future is ours, no need to hide. No need to hide. No need to hide. We are the dream. dream, we are the dream.